ETFE facade, one of the upcoming popular facade material choice for many architects around the world. Developed by DuPont during the 1970s as a lightweight, heat-resistant film for the aerospace industry, ETFE has now become a popular choice for various projects within the agricultural and architectural industries. From an extremely long lifespan, extraordinary tear resistance, to its ability to have a varying degree of transparency and the ability to have a self-cleaning effect, ETFE is an extremely versatile material with various unique properties that can almost suit any architectural projects around the world. The construction of an ETFE facade begins at the manufacturing warehouse facilities, whereby the ETFE film will be measured and cut to the desired shape of the facade panels. Next, the plastic will be heated along the edges to create a small gap in groups of 5 to 2, depending on the number of layers. The heated film will then have rubber ropes inserted into the small gap and tied up, with the lip profile slid onto the rubber rope to allow for the ETFE film to be clamped on to the frame later. C-channels will be welded onto the circular transoms within the warehouse to be assembled later as well. The aluminum base profile, the base seal, cap seal, and the ETFE film will then be transported onto the site to be assembled at a later stage. The construction of the ETFE facade on site will be similar to the stick curtain wall construction, as the design of the building requires a 2.5 meter setback of the ETFE facade. Circular beams, which will be used to support the ETFE facade, will be mounted onto the building's I-beam structure through bolting of the welded T-shaped metal plate onto the web of the I-beam. Next, circular mullions are used to fix onto the beams on every level using bolts and nuts. Circular profile mullions, transoms, and beams are used to keep the entire structure more lightweight looking compared to regular I-beams or IHS. Next, circular transoms with C-channels welded on are attached onto the mullions using bolts and nuts, creating a frame for the ETFE to be attached on later. Piping and tubing for the later inflation of the ETFE pillows are then secured onto the internal web of the C-channel using bolts and nuts. Another C-channel is then attached to the currently mounted C-channel to cover the main piping of the air supply for the ETFE pillows. The aluminum base profile will now be bolted into the C-channels on all 4 sides, with the base seal laid on top of it. Finally, the ETFE film will be fixed into the aluminum base profile with the cap seal placed on top of it, and another aluminum capping to be bolted into the aluminum base profile to seal the whole panel together.